Hello. Let us continue with our analysis of the relationship between perception and reality. The important point is this: perception is relative and relational. It depends on the observer, its scale of perception, etc. What if the same apple is not observed by a human, with his macroscopic scale of perception, but by a cell, with its microscopic cellular scale of perception? What will I perceive if I am a cell? Will the cell perceive the apple like this? No, the cell will perceive the apple as follows. Millions or billions of cells, according to its microscopic cellular scale of perception and according to the scale of the cell's size. For the cell, the apple does not exist as a single, material object, but as a dynamic system made up of millions of cells. Like our perception of a huge gathering of individuals. This means that for the cell, there are no material objects as we perceive them. The same applies if the observer is a molecule, if I am a molecule. For the molecule, with its microscopic molecular scale of perception, the apple does not exist as millions of cells, or as a macroscopic material object, but as billions upon billions of molecules. The same applies to the atom, with microscopic atomic scale of perception. The same applies to the quantum, with microscopic quantum scale of perception. The same applies to the subquanta, with microscopic subquantum scale of perception. Good evening. Let's continue our exploration of the relationship between perception and reality. Perception is therefore relative to the observer, to their scale of perception, to the scale of what is perceived, to the process of perception, and so on. Let's revisit our famous apple. It is perceived differently by different observers depending on their scale of perception. If it is perceived by an agent with macroscopic scale of perception, such as a human, then the result of that perception is precisely the material, solid, red, spherical object that we usually perceive. This observer will conclude that the apple in itself, the reality of the apple, corresponds precisely to this material, solid, red, spherical object. Similarly, consider the case where the same apple is perceived by an agent with perception on a microscopic cellular scale. Let's say it is perceived by a cell. How will the cell perceive the apple? It will not perceive it as a material, solid object, etc., as it is perceived by a human. The cell will perceive the apple much more as millions of cells. The cell will conclude that the apple in itself is these millions of cells. A similar line of reasoning applies in the case where the agent perceives on a microscopic molecular, atomic, or quantum scale. Our perception of the same apple changes as the scale of perception changes. At the molecular level, the apple is perceived as a community of molecules. At the atomic level, it is perceived as a community of atoms. And so on. We therefore find, for the same real entity, the same apple, different perceptual descriptions, different appearances of the same reality, due to differences in the observer's perceptual processes and scales of perception. It is therefore important to distinguish between the appearance of a thing and the reality of the thing. We actually tend to fall into what might be called the illusion of perception. We tend to identify the reality of an entity and the world with a particular appearance of that entity and the world, resulting from a particular perception by a particular category of agents, according to a particular scale of perception. For example, humans are so accustomed to perceiving things and the world according to their macroscopic scale of perception that they believe their perception places them directly before the reality of things. They believe that their perception does not depend on their scale of perception. They believe that any perception will always produce the same perceptual description. They believe that this description simply represents the reality of things. Human is certain that the reality of the apple he perceives is simply that material, solid, red, spherical object which he perceives according to his scale of perception. He is unaware of, or overlooks, the fact that there are different scales of perception that lead to different perceptions of the same reality. Understanding that perception depends on the observer's scale of perception and that there are different scales of perception leading to different appearances of the same thing leads us to realize the need to distinguish between the appearance of things and the reality of things. Another very important point is the difference between the perceptual description of the world and the scientific description of the world. The scientific description of the world is based on two fundamental observations. The first observation is that natural entities are composite entities. For example, the human body is composed of organs, an organ is composed of cells, a cell is composed of organelles, an organelle is composed of molecules, a molecule is composed of atoms, an atom is composed of quanta, and so on. The second fundamental observation is that no natural entity is truly a static substance occupying a volume, but rather possesses a dynamic nature, a becoming, a temporality, and a history. Therefore, naturally, any natural entity must be modeled as a dynamic system rather than as a static substance occupying a volume. At the scientific level, a dynamic system is studied using two opposing approaches. A reductionist approach that reduces the system essentially to its components, and a systemic approach that takes into account, in addition to the components, their organization, interaction, and interdependence, as well as the system's interaction with its environment and other dynamic systems. The systemic scientific description is entirely different from the perceptual description, which is generally a substantialist description. In contrast, the systemic scientific description produces a non-substantialist model and description, alongside, of course, other possible models. Another very important point is the relationship between society and individuals. A society is generally modeled as a dynamic system. It is clear that a society is not composed of matter, of substance occupying a volume, but rather a dynamic system composed of individuals in relation and interaction. In contrast, an individual, say, a man or a woman, is usually considered to be a body of matter or substance that occupies a volume. But in reality, this difference between society and the individual is illusory. Why? Because, in reality, an individual is itself a society of organs that are interconnected and interact with one another. Similarly, an organ is a society of cells, a cell is a society of organelles, an organelle is a society of molecules, a molecule is a society of atoms, an atom is a society of quanta, and so on. Thus, according to the scientific and philosophical study of the physical world, the world is in reality composed of dynamic systems that are nested and interacting, and not of substance. That is truly something fundamental. So the revolution against substantialism begins with the study of the relationship between perception and reality. The conclusion drawn from this study is that perception does not present the reality of the world. It produces an appearance of the world, and in fact this appearance is deceptive because the world appears to us as consisting of matter, of substance, whereas in reality it does not. Matter, as substance, is truly a mirage, an illusion. The world is not made up of matter, substance, or material objects, but of nested, interconnected, and complex dynamic systems. The search for the reality of the world should be based on science and philosophy, not on perception and the resulting appearance of the world. Science, starting with contemporary physics, confirms these revolutionary conclusions. Let us recall that the current global system is based on materialism, capitalism, individualism, and consumerism. Together, these four elements form a system that serves as the foundation of today's global civilization. This system and this civilization have led, and continue to lead, humanity and nature toward disaster and self-destruction. However, this global system, as we have emphasized, is ultimately based on a mirage, an illusion, and an error, namely, materialism, which asserts that only matter truly exists, and substantialism. We are therefore, unfortunately, living within and according to a vast and grave illusion and error. There remains one important point to emphasize. One might think that, given everything we have just said, our perception is flawed. No, our perception is perfect for our everyday life. It makes our lives much easier, but it is not adequate for understanding the reality of the world. If we wish to understand the reality of the world, we must turn to philosophical and scientific reason, with an open and wise mind. In conclusion, the demise of materialism begins with an examination of the relationship between perception and reality. The only possible outcome left for materialism and substantialism is to assert or demonstrate, through quantum physics in particular, that the ultimate constituents of the physical world, namely subquanta such as quarks, gluons, photons, and electrons, are elementary particles of matter. However, as the book Science Proclaims Materialism is Dead demonstrates, contemporary physics leads to the opposite, to the revolutionary conclusion, namely, that subquanta are not elementary particles of matter. Hence, of course, the crucial importance of studying how science, and contemporary physics in particular, declares the death of materialism.